fundamental service type in Kubernetes that works seamlessly with Kubernetes DNS to enable internal communication between services and pods within a cluster. Here's how it operates. 1. Service and ClusterIP creation. When a service of type ClusterIP is created, Kubernetes assigns it a stable internal IP address, ClusterIP. This IP is accessible only within the cluster, providing a mechanism for pods to communicate. The service is also associated with a DNS name, which simplifies addressing services instead of using raw IPs. DNS integration. Kubernetes DNS automatically creates a DNS entry for every service in the cluster. The DNS naming convention typically follows the format: service name, namespace, svc.cluster.local. Example, for a service web service in the default namespace, webservice.default.svc.cluster.local. The DNS name resolves to the cluster IP of the service. 3. Internal communication. Pods communicate with services using their DNS names instead of hard-coded IPs. When a request is sent to a DNS name, Kubernetes DNS resolves it to the service's cluster IP. The service then routes the request to the appropriate backend pods, matching the service's label selectors. 4. Traffic routing. Kubernetes uses IP tables, or IPVS, for traffic routing. Traffic sent to a cluster IP is routed to backend pods using load balancing mechanisms. Requests are evenly distributed across pods, matching the service's label selectors, ensuring efficient traffic handling. 5. Dynamic updates. Kubernetes automatically updates service backends and DNS entries when pods are added or removed. This ensures that traffic is always routed to available pods without manual configuration. Benefits of ClusterIP and DNS integration. Simplified service discovery. Pods can use easy-to-remember DNS names instead of managing IP addresses. Load balancing. Traffic is distributed evenly across backend pods. Dynamic updates. DNS and service routing adapt seamlessly to cluster changes like scaling or rolling updates. Namespace isolation. DNS names include namespaces, preventing conflicts between services with the same name in different namespaces. Use case example. In a microservices architecture, a front-end service communicates with a back-end service. The front-end can call the back-end using the DNS name, backendservice.default.svc.cluster.local. Kubernetes DNS resolves this to the backend's cluster IP, routing the traffic to one of the backend pods. Summary. Cluster IP, combined with Kubernetes DNS, creates a robust, scalable, and seamless mechanism for internal communication in Kubernetes.